Hello, this is Sean Hargrove. This is the demonstration for how to do the fluid analysis for the first fluids assignment. These analyses are done in ANSYS. And to start off, you're going to go over to this side and drag in fluid flow fluent into your workbench, your little project schematic. And we're going to start with I'm gonna do the geometry and mesh through, but to do it, the difference between Coet-Poiseuille and Coet-Poiseuille, you're basically gonna do the same thing, unless you need to change the geometry a bit to have your Reynolds number be small enough. But you're gonna wanna, so if you let it load, and then if you right click, come on, right click geometry, and then go into the new design modeler, and then let that load. I'm gonna have it so that we're in the XY plane, and then what you're gonna want to do is go into sketching and then create a rectangle, try to center it around the origin, and then we're gonna go down to dimensions, stay in general, zoom in, and then if you click aside and then do this, you can get the height and the length. I would go and set the units to millimeters because it's going to be very small what you're working in, and then set it to whatever height and length you've already have preset. I have it as 10 millimeters in height and then 1500 in length. And then after you do that, you're going to want to click get out of sketching, and then you're going to want to add a, where is it again? Oh, not there. You're going to want to add a surface from sketches, and then you're going to want to do the box select, oh, let me get the whole thing, box select, you're going to want to select the whole surface and then apply, and then click generate, and then you will have the whole surface as a surface. And that's all you need to do in the geometry, so you can close out this window and you see the check mark and it's updated. So then we're going to want to double click, go into the mesh, let it load, and then we're going to have it in the XY plane again. And what we're going to want to do is, before we start, I like to go over here, select edge, and then just kind of name your edges so it's easier to work with later. So I'm going to name this one, actually not in there because it doesn't prompt me with a name when I do it like that. Click this, and then you right click it, and then create name selection. I can name this inlet, and then click the right one, and then name this one outlet. Name this one bottom plate, and then this one can be top plate. After you do that, then we're going to want to go over here, click mesh. You still have edges selected, and then click the bottom, and then if you hold control and then click the top, you can select both of them. And then after you do that, you're going to want to right click mesh, insert, and then sizing. And so now we're going to select the sizing of our mesh. We're going to change it from element size to number of divisions, and then I set mine at the length, so 1500 divisions. We're going to make no capture curvature and change the behavior to hard. And then after you've done all that, go up here and click generate, and it should take a minute. The top and bottom plates take a little while because it's long. You can see it down here, the progress, and now that's done. So now if you click mesh, you can see that we have the mesh set, but if we zoom in, you can see it's a bit wonky because we need to set a few more. So we're gonna go back to selecting edges. I think we're already on mesh, yeah. So then we're gonna select the inlet, control click and select the outlet, and we're gonna insert and add another sizing mesh. And again, we're gonna change element type to number of divisions. I change this one to 50 divisions, and then capture curvature, no, set the behavior to hard again, and then generate this mesh. Yep. And then if we click mesh, it's almost ready. It's pretty nice, but if you go to the edge, some wonkiness going on here, so we're going to right click on mesh one more time. This time we're going to insert a face meshing. You're going to click the entire body, click apply, and then generate that mesh. And now if we click mesh and zoom in, there's no more nonsense going on. We've got a nice grid pattern. And that's it for the mesh. These two processes, creating the mesh and the geometry, shouldn't change too much between your different flows. The only reason you would need to change something is maybe your Reynolds number is too big for some of the values we need to put in the setup, so you want to change your geometry. But how you the mesh shouldn't change. How you do the process is the same. So we're going to go right click mesh, click update. It'll update to this thing so that it knows whenever you go into your further processes, the mesh, how the mesh is set up. It's going to take a little while. And once you get that green check mark, that's how you know you're good. So then we're going to double click setup, click double precision, and start that up. We're going to have a window pop up. And this is where you're going to change all of your parameters for your Couette and your Poisal and your combination of two. We're going to do Poisal first because that's how I started. I started it with Poisal. We're going to let this load. And now we're going to go through some of the general things. If you go into models, for every one of your solutions, you're going to want to go over to models, go to where it says viscous SST K omega, double click this and change it to laminar because we want to do everything in laminar flow. And then you can minimize this, and you want to go to fluids and then double click on air. And this is where you're going to set whatever density and viscosity you've calculated to have the Reynolds number you want. I kept my density simple. I kept it at 1. And for Poisal, I had my viscosity at, let me check. My viscosity is 1 times 10 to the negative 5. Alright. So then do that, click change and create, close this. If you want to double check, you can double click fluids and see that it's got air as what it's using. And then we want to set the boundary conditions. So we go over here to inlet and make sure this is, we want to change the inlet velocity for the pressure. Again, this is depending on what you want to choose for your Reynolds number to be nice. You might have to play around a bit to have a nice Reynolds number, but also a velocity that makes it so that on your charts later it's actually like a visible. I chose 0.004 meters per second for my inlet velocity. You want to apply that and close it. That's all you need to do for inlet. For outlet, double click this. You just want to make sure that you prevent reverse flow so we don't have any weirdness going on. We just assume that it's always going through. So click prevent reverse flow and then apply that. Then you can close out of that. Just make sure I did apply that. Yeah, okay. And then we want to go to the walls and make sure that your top and bottom plate are stationary and aren't moving. Are stationary and they have no slip. So the top one and the bottom one, those are good. Keep it like that. And then you make sure all your reference values are good for your inlet, not outlet, because this is this is how the flow is going to be determined. For your calculations, so we have the inlet velocity, we have the viscosity, the density of the liquid. That all seems good. And that's pretty much it for your Poisson. That's all you need to do to change to get your flow going. I guess I'll come back to show you what you would do for co-wet and then the combination. What you're gonna want to do is go to double click initialize and initialize this so that it's ready for you to run your calculations after it says it's done down here. Double click run calculations. Change your number of iterations. This is how many times it's gonna run it to get an accurate reading. You should do like a couple hundred. I do 200 iterations and then click calculate. It's gonna take a while. Okay. After that, you're gonna want to go over to results, double click results. You drag it in. And we're gonna want to, for the project, we need to check the velocity vectors from the mid and end point. So we're gonna make 2 lines. We'll call this one mid. And you're gonna want to make this half of your length. So for me, it's gonna be 0.75. And then this should be 0, from 0 to 0.01, and make 100 samples, and then click apply, and then this will make a line here. We're gonna make another line, name this one end, and then we'll make this one the end of it, so 1.4. Just make it just before the end. If you make it the end, you get some weird like extreme values going. So I just like do like 0.001 off or something like that. We'll apply this. We'll get a line basically at the end, and then we're gonna need a contour. So create a contour. We're gonna want to make it symmetry 1. 110 contours. The variable should be the u velocity, because that's what we're looking for, and apply that. And now we have it. We can zoom in to see what the contour vector velocity is looking like. This is before the flow develops right here. You can see it's not fully uniform, but as you scroll in, it's a nice and uniform bar. If you want to move this, by the way, if this is in the way, you can just go over here to the legend, make this horizontal, and apply that, and then this is out of the way. And if you want to get the ease out of here, you can change it from scientific to fixed. And that's how you get the vectors, the contour map. If you need the chart, you're gonna want to go over to here and then click chart. Change whatever the title you want. the data, we're going to want to add two data series. This series is going to be for the midpoint, and this series is going to be for the endpoint. This is where it's going to grab velocities from. You should make the x-axis your u velocity, and then the y-axis the distance from the bottom wall. And then if we click apply, we can see we have the graph for your velocity, and I think I forgot. You got to make sure, I must have forgotten in the step where I created the line. You got to make sure that you set your line to 110 samples. You can see this is just 11 samples, so the curve is not as defined as the midpoint. They should be the same whenever you make it. If you make it, you'll see like, oh, you only see one line, you don't see your endpoint or your midpoint. By the time it gets to the mid, it's fully developed, and it should be at the end, so their velocity curves, their velocity with respect to height curve should be the exact same. You just need to make sure you give enough samples so your curve's smooth and gives accurate results. That's basically it for the coet. If we exit out of here, if you want to do Poisson, then keeping everything the same, you'd go into setup, and instead of an inlet velocity, you would right click this and make the type. So yeah, you'd go into the boundary conditions, right click inlet, make the type a pressure inlet instead of a velocity inlet, and make sure you click prevent reverse flow, and then keep all of these 0 and click apply. The outlet should stay 0. Make sure it's got prevent reverse flow. Apply that and close it. And then before I change the wall, I almost forgot, you should go to fluids and change if you need to make any changes so that your Reynolds number stays below 2300. You want it, the lower the better. It seems like it'll, the closer it is to very low, you'll get accurate results. So I made this 10 to the negative 3, a bit higher, because I wanted to make, I believe that's all I changed. Yeah, I made it very high because I wanted keep the bottom plate stationary, no slip, but I wanted to change the top plate's moving velocity to 10 meters per second. Whenever I made it very low, I didn't get to see much of a change. Apply that, and then make sure your other values are good, like your reference value. You double click this, and then make sure the density is still your density. Make sure that the velocity from the inlet should now be 0, and make sure the viscosity is wrong. Make sure the viscosity is right. I'm gonna just double check the air. Yeah, that's good. Make sure you have this set to laminar every single time you go over here. Go to model viscous and make sure it's laminar. But then you check this. This seems to be all good. So then you go over here to initialize, hybrid initialize, let it go through, and then you want to go to run calculations, 200 iterations, and then click calculate. We'll let this run. And think about it, I probably should have closed out of the results so it doesn't mess anything up. And then this one's calculations are complete. We'll close out of this one. Let it write its results. And then we're going to go back into results and see what difference that made changing it. As you can see, since I just changed it in the other one, I still have all my stuff typed up, but if you want to do individual ones, you're going to have to make it all again. You can see that after we get to the developing flow, the contour map is a nice rainbow. You can see that up the top is the highest velocity and the bottom is 0 because we're moving the top plate and it's just dragging it. It has a nice linear velocity profile. If this is a separate one, you want to go through and make sure you add the 2 lines again in the contour map. But if we go to the chart, I think I have to insert a new. No. Double click the chart. Insert the chart again. I'm gonna change the. I think it's the end line that was the problem. Yeah. We're gonna make this 110 samples and apply that. Is the mid one on 110? Okay. As you can see, the lines are very, very close. It's in linear. They're not like a parabola. As you get higher up, the velocity goes up to 10. 10 is the max. For both of these, okay, I need to go back into the table, the chart. For both of these, when you're tabulating your results, you can click export here and export it to a table so you can see like the values. You can get the actual values per height. Also, why you want to make sure that these lines are 110 samples or 100 samples, because then you can get more accurate readings. If you do like 10, it'll give you like at 0 it's 0, at like 20% it's whatever, and you don't get like in between. Especially for the Poisel and the combine, you might not get the like true maximum. You just get like an estimate. But that's it for Coet. If we X out of this, doing the Coet and Poisel is pretty simple. Did I mess something up? No, I didn't. Alright, start this back up. As you can see, once you get the geometry and the mesh set up, and then you do your math, changing it from Coet to Poisel to both is pretty easy. I'm gonna wait for this to load back up one more time. Okay, and whoa. Alright, now it's set back up. Now we're going to want to change it one more time. So again, make sure that this is laminar. You're going to want to go over to materials, go to air, double click it, and then change it to what you need. I kept density 1 again, but this time this is 10 to the negative 4. Change and create. Close this. And then you can double check if you need to. This is still pulling from air. We're going to want to change the boundary conditions one more time because we need this to be not pressure. Change this type back to velocity inlet. And we want put your inlet velocity. Again, you put this for your Reynolds number, whatever you have for your Reynolds number. It keeps it nice and low. I have inlet velocity here at 0.8. We'll apply that and close it. Let me just make sure, yeah, everything's good. And then outlet, you just the only thing you need to do in Outlet is for all these is just make sure that there's no reverse flow. So make sure this box is checked and click apply, then leave. Then we want to go to the walls. The bottom plate should be stationary, no slip. Apply that and then close it. And then the top plate, we want it to be moving this time, but if we have 10 meters per second, it's going to overpower it. So it should be somewhere around the speed of the pressure, or the inlet velocity. So I have this as 0.05. We're going to apply this and then close it. Yeah. And then close out of that. Make sure your reference values from the inlet are nice. Density is 1. Viscosity should be 10 to the negative 4. And then this velocity is 0.8. Yeah, this is selected. So change those, and then we just go to the initialization again, hybrid initialization, then run the calculations, calculate it, let it go through it. It's done its calculations. You can click off, go to results one last time. And we can see how it looks. You can see after the flow develops, it's kind of like Poisson, except the top plate is moving a bit, so its maximum is going to be somewhere in the middle. When I did this, I also looked at like the developing flow, because it gave a good, like, I made a line somewhere in here to show the developing flow, because yeah, you don't need to, it's not required for the thing, but it gave a good view as to how this is I guess you can actually kind of see it right now after looking at the other one. You can see how it's shifted up based on the velocity the plate's put, and also this is offset at the top. It's a nice 0.5 meters per second. Again, you would want to go up here and insert the 2 lines, and then add your contour map, and then export it here. You can export your values to a chart so that you can get all those values for your table. And that's pretty much it. Let me go back to the 3D viewer. Yeah. I can pull up my my Google Docs, so you can see how I have it set up. I have the simulations here. I have a picture of my contour, the profiles, the tabulated maximums for the height versus the height, the velocity versus height, and then here is the density and the dimensions, viscosity, inlet, the Reynolds number, and you do this for all 3. Yeah. And that's pretty much it.